Good evening. My presentation is about Vernier scale design for 1/10 mm caliper resolution. In a previous presentations, I have talked about the way how to read the metric Vernier calipers, and we know that we have three different designs for the metric Vernier caliper. We have the least value of resolution, which is 1/10 mm, and in this case the Vernier graduation is divided into 10 equal partitions. In this Vernier caliper we have three designs regarding the length of the Vernier scale. We have a scale of length 9 mm, we have 19 mm, and we have 39 mm. The second type of Vernier caliper is the one which read with a least count of 500 millimeter. In this case, the Vernier caliper or the Vernier scale is divided into 20 equal divisions. In this type of Vernier caliper, we have two styles or two designs regarding the length of the Vernier scale. We have 19 mm and we have 39 mm. And finally, the highest resolution is the one with 200 millimeter, and in this case this caliper is the scale is divided into 50 equal partitions, and for this Vernier caliper we have only one style, and regarding the length of the Vernier scale it is only 49 mm. We need to understand how these values of different length of Vernier scale comes, and how the least counts comes. So let's start with the least value of the resolution for the 1/10 mm. As you see here in this photo, we have a Vernier caliper with 1/10 mm resolution. So this is called the least count, and we know how to get this value of least count. Simply, we have said that in order to compute for this value of least count, we divide this minimum distance on the main scale by the total number of divisions. So the minimum reading on the main scale is 1 mm, and regarding the number of divisions for the Vernier scale we have 10 divisions, so the least count is 0.1 mm. So this is the way how this value comes. But now we need to understand this concept in different ways. Let's start understand how much the length of this Vernier scale. For example, if we try to open the caliper a little bit so that the first line lines up with this line, so the last line on the Vernier scale should line up with this line. So the length of this Vernier scale is simply the distance between these two lines on the main scale. And in order to get this value, this line is line number 22 mm, and this line is line number 14 mm. So the difference between 22 mm and 14 mm is simply 9 mm. So the length of the Vernier scale in this case is 9 millimeter. So in order to compute for the distance between two adjacent lines on the Vernier scale, which means this distance, simply we can compute for this distance by dividing the total length of the Vernier scale, which is 9 mm, by number of divisions. So we have 10 divisions. So the distance between one line on the Vernier scale and the adjacent line is 0.9 mm. So this line on the Vernier scale is simply 0.9 mm. And regarding the distance between two adjacent lines on the main scale, it is simply 1 millimeter. So the least count is simply the difference between the minimum reading on the main scale and the distance between two adjacent lines on the Vernier scale. So in this case, the Vernier graduation number or divisions, we have 10 divisions. So the length of one Vernier graduation on the Vernier scale is simply the total length, which is 9 mm, divided number of divisions of this Vernier scale, and the value is 0.9 mm. So the least count is simply the difference between the minimum dimension on the main scale and the minimum dimension for one graduation on the Vernier scale, which is 0.9. So the difference is 1/10 mm, which is the least count. Imagine that if we have a length of a Vernier scale, instead of having length of 9 mm, let's imagine that we increase the length of this Vernier scale by 1 mm so that it becomes 10 mm. So what will happen in this case? In this case, if the new length of this Vernier scale is 10 mm, so the length of one graduation is simply equal to the length of the Vernier scale divided by the number of graduation. So in this case, we will have a length of 1 mm. So instead of having 0.9 mm on the Vernier scale graduation, in this case, we will have 1 mm. So in this case, this distance is the same as the minimum distance on the main scale. So in this case, imagine that the caliper is totally closed so that all the 10 lines will line up with 10 lines on the main scale. And if you try to open the Vernier caliper, then there will be an offset between each line on the Vernier scale and each line on the main scale. So in this case, the Vernier caliper doesn't work. So how to solve for this problem? Instead of having 10 mm Vernier length, we have 9 mm, and this 9 mm length is divided equally to 10 partitions. Let's see the other design for the Vernier scale length. As you see here, this is the same Vernier caliper with 1/10 mm resolution, because simply we have a Vernier graduation of 10 partitions. So regarding the length of this Vernier scale, imagine that we move the Vernier scale to the left so that the first line on the Vernier scale lines up with this line. So in this case, the last line on the Vernier scale, which is this line, will line up with this line. So the length of the Vernier scale is simply the distance between this line and this line. So in order to compute for this length, simply this line is line 39 mm and this line is line 20 mm. So the difference between these two lines is 39 minus 20. So 39 mm minus 20 mm, it's equal to 19 mm. So in this case, the Vernier scale is longer than the previous one. So we have a Vernier scale of length 19 mm. So this is the second style. So if one asks how much the distance between these two lines on the Vernier scale graduation, simply we can compute for this distance. The total length of the Vernier scale is 19 mm, and the number of divisions is equal to 10. So this distance is simply 1.9 mm. So in this case, the distance between two adjacent lines on the Vernier scale is 1.9 mm instead of 0.9 as the previous design. So this distance is 1.9. And if you compute for the distance between one line on the main scale and the next line or the line to the next, this is simply 2 mm. This is simply 2 mm. So one Vernier graduation length, it's equal to 19 divided by 10, so we have 1.9 mm. So the least count is simply the difference between two lines on the main scale and the one division on the Vernier scale, which is 1.9. So in this case, we have a least count of 1/10 mm. Imagine that instead of having a Vernier scale of 19 mm, we have a Vernier scale length which is more 19 by 1 mm. So if we have a Vernier scale of 20 mm, what will happen in this case? In this case, the length of one division on the Vernier scale will be 20 mm divided by number of division, which is 10. So in this case, the length of one division is 2 mm. So in this case, instead of having 1.9, we have 2 mm, and see that we have also the same distance, which is 2 mm on the main scale. So in case the Vernier or the caliper is totally closed, all the 10 lines on the Vernier scale will line up with 10 lines on the main scale. And if you try to open this caliper, all of the Vernier scale lines will be offsetted by a same value regarding the main scale lines. So in this case, the caliper will not work correctly. So this is the second style of the 1/10 mm resolution Vernier caliper. In this case, the length of the Vernier scale is 19 mm. So as I have said, this distance is equal to 1.9 and this distance is equal to 2 mm. So in order to have a caliper with 1/10 mm reading, we should move this line on the Vernier scale right so that it lines up with this line. So in this case, the least count is simply the difference between these two lines on the main scale and the difference between these two lines on the Vernier scale. So the difference is 2 minus 1.9, which is 1/10 mm. So in below, we open the caliper so that we have the minimum reading or the least reading. So as you see here, the first line on the main scale lines up with this line. So this distance or this offset is the reading of this caliper. So we have 0.1 mm. Let's see the third design of the 1/10 mm resolution vernier caliper. In this case, this caliper with 0.1 mm resolution is closed. So the length of the vernier scale is simply the distance between the 0 line on the main scale and line number 39 on the main scale. So in this case, we have the longest length of vernier scale, which is 38 mm. So if one asks how much the distance for one division on the vernier graduation or vernier scale, this distance, simply we can compute for this distance by dividing the total length of the vernier scale, which is 39, by number of divisions. We have 10 divisions. So one division on the vernier scale is simply equal to 3.9 mm. So this distance is equal to 3.9 mm. And regarding the distance on the main scale between the 0 line and line number 4, this distance is simply 4 mm. So the least count is the difference between these two distances on the main scale and on the vernier scale. So the one vernier graduation length, as we have computed, is equal to the total length of the vernier scale, which is 39, divided by 10 divisions. So one graduation is simply 3.9 mm. So the least count in this case is equal to 4 minus 3.9, which is 1/10 mm. Imagine for this design of vernier caliper with 1/10 mm, instead of having a vernier scale of 39 mm length, we have more by 1 mm, so that it is 40 mm. What will happen in this case? If you try to compute for the one division on the vernier scale regarding its length, so simply you can get it by dividing the total length of the vernier scale by the number of divisions. So in this case, we will have 4 mm. So what will happen in this case? This distance, instead of being 3.9, it will be 4 mm. And also this distance on the main scale is 4 mm. So what will happen? Simply the 0 line on the main scale will line up with the first line on the vernier scale, and also line number 4 on the main scale will line up with the first line on the vernier scale. And regarding the second line on the vernier scale, it will line up with this line, and regarding the third line, it will line with line number 12 mm, etc. So in this case, all the 10 lines will line up with 10 lines on the main scale. So in order to solve for this issue, instead of having 40 mm length, we have 39, and we divide this 39 mm length into 10 partitions. So this is the way how to get a 1/10 mm least resolution for this vernier caliper. So in general, in order to review the the different styles, as you see here. For the 1/10 mm resolution, the number of graduations for the Vernier scale is 10. So we have 3 different styles or 3 different designs. We have the least length of the Vernier scale, which is 9 mm. We have 19 mm, and we have the longest one with 39 mm. So instead of having a Vernier scale of 10 mm or 20 mm or 40 mm, we have 9 and 19 and 39. So this is the concept of the least count for the 1/10 mm Vernier scale for the caliper. Thanks a lot for your watching. Goodbye.